Now you may have noticed in that last lesson where we were learning about what all the symbols in a chemical equation means, like the plus sign and the arrow and the state symbol, solid, liquid, gas, aqueous. You may have noticed that on each one of those slides, I had a description of the chemical reaction and a chemical equation. Now, in this lesson, what we're going to do is we're going to practice, starting with those descriptions, writing our own chemical equations. And a hint, one of the most important skills here is being able to write formulas by checking charges. So you're going to see that skill that we learned in the last unit is going to show up a lot in what we're doing today. So let's jump in here and get it to go. There we go. And let's look at one of these descriptions. So solid magnesium metal is mixed with chlorine gas to form magnesium chloride. Now obviously if we want to turn this into chemical symbols, the thing we need to notice is there are a number of actual chemicals in here. There's chlorine, there's magnesium, and it's a good idea to underline all those chemicals and make sure that you don't miss any of them when you're drawing them down. The other thing I like to do is I like to come in here and I like to make sure I know where the plus signs and the arrows are, that sort of thing. So let's read this. Solid magnesium metal is mixed with, I think that's the plus sign, right? Is mixed with chlorine gas. So clearly I think these two are going to be reactants to form, I think that's the arrow, magnesium chloride. So this must be the product, right? So we're going to have this on the right side of the arrow. We think this is a reactant. And we think this is a reactant. I call this diagramming the sentence, as in trying to figure out where the arrow is and where the plus sign is. So if we were to start writing this down, I would say magnesium is Mg. It's mixed with chlorine gas to form magnesium chloride. Now obviously we aren't done here. For starters, I didn't put the state symbols in. Now sometimes in the description it's really hard for you to know what the state symbols are, but if we can, we'll put those in just a second when we get done. But you know there are some other things that are probably bugging you a little bit here too, which is this is a chemical compound, right? Remember in the last unit, if it had said magnesium chloride, we would have needed to check charges there. In other words, we would have needed to come out here somewhere and say, okay, I think Mg is, well, 2 plus, and chlorine is -1. Do we need more magnesiums or chlorides? We definitely need more chlorides, and so there we go. I've an equal number of negatives as positives. So my formula would be 1 Mg and 2 chlorides. It would be MgCl2. So that's the first thing that you've got to understand about the two most important rules when writing chemical equations. The first one you already know. Check charges on all compounds. This thing was a compound. It was made up of two different elements. You need to check its charges. Super important. We don't need to check the charge of chlorine, and we don't need to check the charge of magnesium because those are elements, right? They're by themselves, right? We're mixing magnesium with chloride, but they're not in a compound together in the beginning. In other words, you would have two different bottles, a bottle of magnesium metal and another cylinder or bottle containing chlorine gas. They're not in a compound, but this one is in a compound. You got to check its charges. So that's rule number one, and that's where those skills from last unit will come in really handy. Now the second rule is completely new for most people, which is you need to watch out for diatomic elements. Like up here we had a rule for compounds, but do we have a rule for elements? Yes. So if we come up here, you see this is an element because it's an atom by itself. If it's an element, you need to look at it and decide, is it a diatomic element? And what I mean by that is, if you ever noticed that oxygen is never written as O, it's always O2, right? Well, there are other elements that are written that way too. They're referred to as the Brinkelhoff elements, just simply because those are the 7 elements that you have to watch out for this. Like if we see oxygen, if we ever see oxygen, we're going to put a 2 on it. If we see hydrogen, we're going to put a 2 on it. Fluorine, chlorine, nitrogen, iodine, and bromine, all of those 7 of those elements are diatomic elements, or I like to call them Brinkelhoff elements. If we ever see them by themselves, we've got to put a little 2 on them. Another way to remember is there are 7 of them, and they actually make a 7 on the periodic table. Look at that, NOFClBri. But if you're counting in that 7 shape, there's actually 1, 2, 3, 4, 5, 6. There's only 6. Where's the 7th one? Well, it's hydrogen. I don't know why it's not next to the others, but here's the other one, hydrogen. So these, they're sort of grouped together on the periodic table, which is really helpful. So I come up here, I don't have to worry about looking at this for diatomic elements. It's the elements by themselves I need to look at. Is it magnesium or chlorine that needs a little 2 next to it? It's chlorine, because chlorine is a Brinkelhoff element, but magnesium is not. So not all elements that are on their own, that are in elemental state, get a diatomic symbol, only those 7. So those are the 2 rules we're going to watch out for. If we see a compound, we're going to check charges. If we see elements by themselves, we're going to check them to see if they're diatomic elements. Knowing the difference between a compound and an element is going to be really important in what we're doing. Okay, let's look at this. I've got a completely new one. I'm going to underline the chemicals: potassium oxide, oxygen gas, potassium metal. Those are my chemicals. Let's see if we can figure out what word in here means the arrow. Decomposed. I think it might be is decomposed into. What word in here means the plus sign? I think it's that, right? All right, so now we know we have one reactant, which is potassium, right? Potassium's KO, is decomposed into, there's the arrow, oxygen gas and potassium metal. So that's the skeleton of my structure. Now here's my question. Is it chemical number 1, 2, or 3 that you actually need to check charges on? Number 1. Only number 1 is a compound. It has 2 different elements and it's a compound. We need to check charges. So let's do that. It says for the compounds, which is only number 1, we got to check charges. So I have K is +1 because it's right there. O is -2 because it's in the -2 column. Do I need more K's or O's? Definitely I need more K's. And what would be the formula in the end? Well, it would take 2 K's, so it would be K2O. Boom, I've checked charges. I like to actually put a check mark to remind myself that I did it. Now I do need to check something about these, but I don't need to check charges here because these are elements by themselves. I do need to check and see, because they're elements, are they diatomic? Is O or K, is either one of them a diatomic, or is both of them a diatomic element? Only O, because O is right there. It's a Brinkelhoff element. K, it's not in that list of 7, so it does not get that diatomic 2 put on it. And there we go. We're done. So for compounds, we got to check charges, and for elements, we got to look for diatomic elements, and only 7 of them are diatomic elements. Let's try another one. Okay, so I want you to work ahead here. I want you to, let's see, tell me, when you read this, which chemicals are reactants, which chemicals are products, what word or words in here means the arrow, and what word or words in here means the and sign. All right, pretty darn good. Now let's see. So we've got fluorine gas. You know I like to underline the chemicals: magnesium metal and magnesium fluoride. Fluorine gas is reacted with, I think that is the plus sign. To make is the arrow. So it looks to me like I have a chemical here and a chemical there. I have 2 reactants: fluorine gas and, that's spelled wrong, magnesium metal, to make magnesium fluoride. Okay? Is it chemicals, which of these 3 chemicals, maybe more than one, but we'll see, which of those chemicals do you need to check charges on? Only magnesium fluoride. And what do you need to check about these 2? If they're diatomic elements, that's right. I like to start with the diatomic elements, so maybe we'll do step 2 first here. So the elements, which are only fluorine and magnesium, is either one of them a Brinkelhoff element? Yes, fluorine is. I see it right there. So it needs a little 2 next to it. Magnesium is not in this list. Now hold on here. I see a fluorine over here. Do I put a 2 on it because it's a diatomic element? Not necessarily. It's not an element, right? It's a compound. So the F would have to be alone for us to just say, hey, there's a diatomic element. I'm going to put a 2 on it. But this one up here is a compound, so we've got to check charges. So let's do that. So we've already finished these 2. I'm going to put my check marks above them. But this one, I got to check charges. Mg is 2+, because it's right there. Fluoride is right there. It's in the -1 column. Do I need more magnesium or fluorides? I need more fluorides. And what's my formula going to be? MgF2. Very good. So it did turn out to have a 2 there, but not because it was a diatomic element, but because I checked charges. Now, a lot of times I will tell you guys, if I have a pencil, I write +2 above this, and I write -1 above that, and I think, oh, I need more fluorides, and I write the 2 down. If you do that, remember to erase your charges at the end. And the reason is because the final compound, you got to remember, has got to be neutral. It's not to hide your work. It's just that final compound's got to be neutral. Okay? All right, so we checked charges, we checked for diatomics, and we're done. All right, let's try another one. So I know you guys want someone that's a little bit harder. Now in this next one, I'm going to stop the video in a second. I'm going to give you a polyatomic ion chart because you might need it here. But I want you to, in your mind, underline the chemicals. Figure out, do I have one reactant or two reactants, one product or two products? Usually there's not many more than that. And then I want you to write out the formula. Okay, I want you to tell me in your formula which of the chemicals in your equation were elements. Those you need to check for diatomics. So check and see if either one of them is a diatomic. Okay, now I want you to decide with the remaining compounds, which of them do you need to check charges? Well, kind of both, but you can see that HNO3, because it doesn't have, well, you could say hydrogen nitrate, right? But in any case, they gave it to us. And if they give it to us, it'll never be wrong. But this one you got to check charges for. Remember, this, is it the number of coppers or is it the charge of copper? It's the charge of copper. And nitrate, you got to look it up on its polyatomic ion chart. So do that and then type in the formula here. All right, let me show you what I got. I've got copper metal, which, by the way, I could put a solid on that, right? Because it says metal, it tells me. Reacts with HNO3, but they don't tell me what that is, so I don't know what the state symbol is. To make hydrogen gas and copper 2 nitrate. So nitrate I looked up on the polyatomic ion chart is NO3. But you're right, I think you just told me that it's these two chemicals right there and right there that are elements on their own. And I like to do the diatomic elements first. Did we decide copper or hydrogen? Are either one of them diatomic elements? Yes, hydrogen is, it needs a 2 because it's a Brinkerhoff element. Copper is not. Now these are compounds. I don't want to check charges or check diatomics here. Here I'm going to check charges. Now this one, because they gave us the formula, I think is already done. But you could see it would be +1, -1. It's good to go. Over here, do we know the charge of copper? Yes, it's +2. And nitrate, I looked up on the polyatomic ion chart, was -1. Do we need more coppers or nitrates? Coppers or nitrates? Definitely nitrates. So I gotta have to do exactly the same thing. Now I've got -2, that's +2. All right, there we go. It's gonna take 1 copper and 2 nitrates. So I am gonna need parentheses before I put the 2 on there. And then remember, if I left charges up there, I've got to go erase those charges. So I'm going to grab my eraser tool, go like that, and there we go. Pretty darn good. I think we did a good job here. We've checked for charges, checked for charges, checked for diatomics, checked for diatomics. And that's it. That's all you have to do. If you want to write a good quality formula, remember, with compounds, check charges, and with elements, check diatomics. That's absolutely right. All right, our last one here. So keep that polyatomic ion chart out, and I want you to write the complete formula here, or the complete reaction here. You can leave the state symbols off because in a lot of these I haven't said, you know, like the oxygen, it says it's a gas. You could put that in if you wanted to. But for the most part, I want you to check charges if it's a compound, and check for diatomic elements if it's an element. All right, it says lithium chlorate. When I looked that up on my polyatomic ion chart, chlorate is ClO3, is heated to produce, it sounds like it's making lithium chloride. See, there's one chemical. This would be nice if it was on one line, was the second one, and oxygen gas. All right, by the way, which of these chemicals need you to check for diatomic elements? Only the oxygen. It's the only chemical that's all by itself that's in its elemental form. This one you might think, hey, there's a chlorine and that's a Brinkerhoff element. But yeah, that is a chlorine. But why is it that I don't just slap a 2 on there? because it's a compound, right? This one too, I see a chlorine, but I'm not going to throw a 2 on there because it's in a compound. It's only this one, and yes, oxygen is a Brinkoff element, so we've checked for diatomic elements. Now for the remaining 2, we've got to check charges, right? Let's do this one over here. Lithium is +1. Chlorate, according to your polyatomic ion chart, is -1. Which side needs more? Neither. You have 1 lithium, 1 chlorate. That one is done. Let's do this one. Lithium is +1. Chloride is right there, so it's -1. Which of those do we need more of? Neither one. So it's good to go. And we have a good quality reaction drawn. So if you have elements, check for diatomics. If you have compounds, check charges.